نبينا محمد وعلى آله وصحبه أجمعين. We are in section 5.1, which is about angles measure. And today we will talk about objective 6 and objective 7. Objective 6 is about coterminal angles. The angles with the same initial side and terminal sides, but possibly different rotations, are called coterminal angles. Both these two angles, you put them in a standard position. When you put them in a standard position, the initial side would be always on the positive x-axis. So all angles in a standard position have the same initial side. If they also have the same terminal side, we call them coterminal. Coterminal means they have the same terminal side. Two angles will be coterminal if the difference between them is a multiple of 360 degrees. So if you add 360 degrees to any angle, 0 for example, the angle 0 and the angle 360 degrees are coterminal because they have the same initial side and the same terminal side. So when you add 360 to any angle, you get a coterminal angle. This is in degrees. So you can say that all coterminal angles to the angle theta are given by theta plus or minus 360 degrees times k, where k is an integer. Integers are -2, -1, 0, 1, 2, and so on. Negative numbers, positive numbers, and the 0. These are the integers. So 0.5 is not an integer, for example. So you add 1, 2, 3. You replace k here by 1, 2, 3. You get another coterminal angle. So there are infinitely many coterminal angles with theta. Whenever you add 360 or a multiple of 360, or you subtract 360 or subtract a multiple of 360, you get coterminal angles. In radians, you add 2 pi k. Okay, to theta, we add or subtract 2 pi k, where k is an integer. 2 pi equals to 360 degrees. So two coterminal angles for an angle theta can be found by adding 360 to theta. By adding 360, you get another coterminal angle. And by subtracting 360 from theta, you get another angle. So here you get two coterminal angles to theta. Once you add 360, and the other time you subtract the 360. Let us try to answer this example. Assume the following angles are in standard position. Find a positive angle less than 360. That's coterminal with each of the following. So the first angle is 420 angle, 20 degrees. Now, there are a lot of coterminal angles to this angle. If you add 360, you will get a coterminal angle. If you subtract 360, you will get another coterminal angle. If you subtract again 360, you will get another coterminal angle. Which one he is asking about? He is asking about a positive one less than 360. So if you add 360 to 420, you will not get an angle less than 360. So try subtracting. If you subtract 360 from 420, you get 60. Now this 60 is positive and less than 360 and coterminal to 420. So the answer is 60 degrees. 60 degrees is the positive angle less than 360, which is coterminal to 420. And you can see that in this graph, this is the angle 60 from here to here. And if you subtract from 60, which means you go in the negative direction, 360, you reach the angle. No, if you add 360 to 60, you reach 420. If you start by 420, you subtract 360. But if you start by 60, you add 360 and you get the 420. So you can see here that 60 and 420 have the same initial side and the same coterminal side, so they are coterminal. What about the angle negative 120? If you add negative 120 plus the angle 360, I am adding here because I need a positive angle. You will get 240. Now 240 is coterminal to negative 120, and it is less than 360, and it is positive, so the required angle is 240. Okay, so 240 would be the answer, and you can see that this is negative 120 in the standard position, and if you add 360 to negative 120, you reach 240. So this is the angle 240 in standard position. They both have the same initial side and the same terminal side, so they are coterminal angles. So you can solve this by yourself. You will subtract here 360 and you will add here 360 to get a positive angle less than 360. That's coterminal with these two angles. Here also the same question. Find a positive angle less than 360, coterminal with 395. 395 is greater than 360, so you subtract and you get 35, I believe. Yeah, 35. So 35 degrees is the positive angle less than 360, which is coterminal to 395. What about the radian measure? Okay, if you want to find two coterminal angles for an angle theta, you add 2 pi, you get one of them, and you subtract 2 pi from theta, you get the other one. But here, let us see, he is asking about what? Assume that all angles in standard position. Find a positive angle. Again, he is asking a positive angle less than, this time he said 2 pi, so it's in radian. 2 pi equals to 360 degrees. That's coterminal. So in the previous example, we added 360 or subtracted 360. Here you add 2 pi or subtract 2 pi. Remember here in part A, for example, he needs this angle, 17 pi over 6. We need to find a coterminal angle to this angle, which is positive and less than 2 pi. Remember, this is pi over 6. The denominator is pi over 6. So in this case, 2 pi equals 12 pi over 6. This is 17 pi over 6. So if you subtract 17 pi over 6 minus 12 pi over 6, because 17 is greater than 12, you get 5 pi over 6. So 5 pi over 6 is the coterminal angle with 17 pi over 6, which is positive and less than 2 pi. 2 pi is 12 pi over 6. And here the graph of the two angles, this is 5 pi over 6, and it is also 17 pi over 6 if you add another 2 pi. So the difference between these two angles, both are positive. The difference is a complete rotation, which is 2 pi. They have the same terminal side, the same initial side, so they are coterminal to each other. Now I need to talk about pi over 12. Okay, I am going to add 2 pi. Remember that in this case, 2 pi would be, I need the denominator to be 12. So I'll multiply 12 by 2, I get 24. So 2 pi equals 24 pi over 12. If you divide 24 over 12, you get 2. So I will add or subtract 24 pi over 12 to this angle. But this is a negative angle. So if you subtract, you will get another negative angle, and I need a positive angle. Okay, so I will add, not subtract. So by adding 24 pi over 12, the denominator is 12. So you just add the numerators. 24 minus 1 is 23. So the angle is 23 pi over 12. This is positive and less than 2 pi, because 2 pi is 24 pi over 12. So this is the required angle, and this is the graph of both of them. This is negative pi over 12, this one in the negative direction, and this is in the positive direction, 23 pi over 12. Both two angles are coterminal to each other. Same question here. Find a positive angle less than 2 pi. In part A, you have the denominator is 5. So 2 pi would be, keep the denominator 5, multiply 5 by 2, you get 10 pi over 5. So 13 is already a positive angle. So I will subtract 10 pi over 5, which is 2 pi, and I get 3 pi over 5, and that's the positive angle less than 2 pi, which is coterminal to 13 pi over 5. Part B, I have a negative angle, and the denominator is 15, so I need to write 2 pi when the denominator is 15. I multiply 15 by 2, I get 13 pi over 15. So I should add or subtract 13 pi over 15. If I subtract, I will get a negative angle. So I need to add 30 pi over 15, and I will get 30 minus 1, 29 pi over 15. This is a positive angle, less than 2 pi, because it is less than 30 pi over 12. Okay, another example about coterminal angles. Find a positive angle less than 360 or 2 pi that's coterminal with each of the following. Same method, okay? But here he mentioned the degree and the radian. If it is given in degree, we work in degrees. If it is given in radian, we work with radians. I will solve with you part D here. Let us talk about part D, because this angle, the measure of this angle is negative 10.3 radian, because there is no circle here. So this is not degree, this is radian, negative 10.3. And there is no pi. So what to do with negative 10 pi over 3? So I need a positive angle. Here, 2 pi, you can work with this method. This is one method. You remember that 1 radian is approximately 57 degrees. It's 57.3 degrees. Okay, so if you can change it to degrees, and find here a coterminal angle to negative 10.3. Okay, so when you change it to degrees, you will get negative 587.1 degrees, and you add 360 degrees to it, and find the angle which is in degrees, and then you change it back to radians. This is one method. The other method which I prefer, I will work with radians. Okay, remember I need to add 2 pi here. Okay, if the question is negative 10.3, just like this, I can talk about 2 pi. Okay, what is 2 pi? If you use the calculator, ask the calculator about 2 pi. So multiply pi in the calculator by 2, you get 6.28. It is 6.28. Okay, so 2 pi equals to 6.28 approximately. So I can start with negative 10.3 and add 6.28. Okay, if you add negative 10.3 plus 6.28, you should get a coterminal angle. This is negative 4.02. This is a coterminal angle with negative 10.3, but it is not good because he is asking about a positive angle and this is negative. So I should add another 6.28, another 2 pi. When you add another 2 pi, you will get, you will get 2.26. Actually, this should be 6.28. So you will get 2.26. So you can say that 2.26 radian is complementary, coterminal, not complementary, is coterminal with with the required angle, which is negative 10.3, with negative 10.3. So simply, I wrote 2 pi as 6.28, and I added 6.28 twice to negative 10.3, and I got 2.26. Well, you can write it 2.3, or it is actually 2.26. This angle is coterminal, positive, less than 2 pi, and coterminal to negative 10 pi to 10.3. Okay, let me solve some of these exercises. I leave these for you, but I will solve this one. 17.4 angles. Okay, so I will take part D. Please try A, B, C. I think they are easy by yourself. Okay, this is 17.4 without pi. So I will write 2 pi as 6.28. And I will start subtracting. 7.4 minus 6. Why subtracting? Because I need a positive angle less than 6.28. So if you subtract 17.28, 17.4 minus 6.28, you get 11.12. This is coterminal to 17.4, but it is not less than 6.28. So again, I will subtract 6.28. Now, if you subtract 6.28, you get 4.48. 4.48 is less than 6.28. So this is the answer. This is the coterminal, the positive angle, less than 2 pi, which is 6.28, and coterminal to the angle 17.4. Some other examples: find a positive angle less than 360 or 2 pi, that's coterminal 2. I believe these are easy here. You will subtract 360. Here you will add 360. Here you will add 360. But maybe if you add 360, it won't be enough because the angle will be still negative. If you add 360, you will get negative 405. So you add again 360. Okay. It is good not to write it like this. You start again and write negative 405 plus 360. I believe that you will also have a negative angle. So this is also not good. So I need to add another 360. All of these angles are coterminal to each other. 315, negative 45, negative 405, negative 765. All of them are coterminal. But the question is, find a positive angle less than 360. So my answer is 315. This would be the answer to the question. 19 pi over 6, you subtract 2 pi, which is in this case 12 pi over 6. So you subtract 12 pi over 6, you get 7 pi over 6. That's immediately the answer. Here, 2 pi is 10 pi over 5. So you subtract 10 pi over 5, but it will not work because 13 pi over 5 is greater than 10 pi over 5. So you need to subtract again another 10 pi over 5, and your answer would be 3 pi over 5 because it is less than 10 pi over 5. Here you add, but you remember that 2 pi here is 14 pi over 7. You add 14 pi over 7. I think you will add 3 times 14 pi over 7 to find a positive angle less than 2 pi and coterminal to negative 31 pi over 7. The last objective in this section is how to find the arc length or the length of a circular arc. We have seen before that theta in radian equals S over R, where S is the arc length and R is the radius of the circle. Here, if you want to solve this equation for S, then by cross multiplication, S would be equals to R theta. So S is the arc intercepted by the angle theta, and R is the radius of the circle, and theta is measured in radian. Remember that theta is measured in radian in this formula. So you cannot use the formula unless theta is in radian measure. So here, look to this great question. Can I apply this formula if theta is in degrees? And the answer is no. The formula can only be used when theta is expressed in radians. So you have to change theta to radians first. If theta is given in degrees, you will need to convert from degrees to radians before using this formula. Let us look to the solution of this example. A circle has a radius of 10. So R, which is the radius, is 10 inches. Find the length of the arc. So he's asking about S because S is the arc length intercepted by a central angle of 120 degrees. So the angle theta is 120 degrees. The relation between SR and theta, we need to find S. So we know that S equals R times theta, but theta must be expressed in radians. So we have to convert 120 degrees to radians by multiplying by pi over 180. So it is 2 pi over 3. And now we can use the formula S equals R times theta. R is 10. Theta in radian is 2 pi over 3. The answer is 20 pi over 3 inches. That's the exact answer. If he finished, that's the answer of the question. He did not say approximates. If he says approximates to 2 decimal places, we can use the calculator, and this would be the answer. This is the length of the arc, 20.94 inches. Please solve this question. Similarly, use the formula that S equals R times theta. So R is 6 inches. Theta is 45 degrees, but it is not accepted. You have to change it to radian. If you know from what we mentioned yesterday that 45 is actually pi over 4, so that would be your answer. So it is 3 pi over 2 inches. This would be the answer, the arc length. Okay, then round your answer to 2 decimal places. So I just write 3 times pi over 2 in the calculator. And if you round to 2 decimal places, you get 4.71 inches. Okay, so this is the arc length. Same question here. Theta is given and R is given the radius. Please find S using the same method. Let us look finally to this exercise, and this is the answer. You need to solve it by yourself, but let me check that it is the same question. Radius equals 8. The arc length, we need arc length, so we need S, which is R times theta by a central angle of 225 degrees. So first you have to change theta from 225 degrees to radian measure, and then you put it in this formula, and you find the arc length first in terms of pi, and then by rounding your answer to 2 decimal places. I stop here and I open the floor for the questions. If you have any question, please ask.